This video is going to be reviewing parallel and perpendicular lines. So if you maybe missed a day or two and didn't get all of the notes on parallel and perpendicular lines, or if you need to review those two concepts, this will be a good video for you to watch. Starting off, let's either open up to your notes on parallel and perpendicular lines, or you can take these down. Parallel lines are two lines that never meet because they have the same slope, which means they rise and they run at the same rate. We talked in class about this. It's kind of like when your little brothers and sisters want to be as old as you are. They think someday that they will catch you, but really we all age at a constant rate, and therefore will never catch each other. Okay? The differences are that you were born before or after your siblings, so you have a different y-intercept there. So we have these two lines here, A, B, and C, D, that both have a slope of 1 over 2. So our slope is 1/2. We rise 1 and run 2. So these lines will never meet because as AB increases by 1, it runs 2, and as CD increases by 1, it runs 2. So they will never intersect. You can see there that the difference is that we have different y-intercepts. Again, in class, we talked about the symbol for parallel are these two vertical lines, and we can make statements such as this one that says line AB is parallel to line CD. Perpendicular lines are two lines that meet at a 90-degree angle because their slopes are inverse reciprocals. And notice down here, inverse reciprocals is when the fraction flips and the sign changes. So the fraction 3 over 4 would go to -4 over 3. The fraction flipping, that's called the reciprocal, and then the inverse is just that sign changing, and we could move that sign. If this negative was at -3/4, then the negative reciprocal would be +4/3. Okay? Again, we have a symbol for perpendicular. It's that upside down T, and then we can make statements such as EF, or the line EF is perpendicular to the line JK here. Okay, and it makes sense that if one line is going to be positive, to cross that line you have to go negative, or if this line is negative, to cross that line at a 90-degree angle you have to go positive. So those are just some general definitions of our parallel and perpendicular lines. Let's look at some examples that we went through in class. So we looked at these two rectangles and within this circle, and we came up with some parallel partnerships here. So the red here, if we look at line GB is parallel to FC, and we've made that statement there. Doesn't matter which way you write BG and CF, you just read them left to right usually. And then we calculated the slope. The slope of GB, we go down 3 and over 1 or over 9. So from 3 to 0 is down 3. From -4 to +5 is a run of 9, and that reduced to -1/3. Same thing for F. We went down from 0 to -3, and over from -5 to a +4, a change of 9. That was reduced to -1/3. FA and EB are similar, but they are going upwards, so we have +1/3. EF and AB, the green lines here, are a steep drop, okay? And so we notice that we go down from 0 to -3, we decline 3, we go down 3, and we run from -5 to -4, a run of only 1. Okay, so -3 over 1, -3 over 1, same thing for AB there. And then GF and BC are just the positive versions of that same line. The big thing to notice here are that parallel lines have the same slope. Okay, all of these pairs have the same slope. And then we went on to perpendiculars. There were 8 sets of perpendicular lines, and if you take a look here, we'll just look at a couple that are on top. If we notice this bright blue lines, we have line AF or FA and FE. And the line FA goes up 3 and over 9, which we decided reduces to 1/3. Okay? It's going over more than it's going up. So that's a way to know that the bigger number is going to be on the bottom. And then perpendicular to that is line FE, which is going down 3 and over 1. So we see that we have a negative 3 over 1 slope there. Notice all of these perpendicular pairs, we have reciprocals, the fraction flipped. 1, 3 went to 3 over 1, 3 over 1 went to 1, 3, 3 over 1, 1/3. All the fractions flipped in these pairs, and then all of the signs changed. So one is negative, one's positive, one's negative, one's positive, one's positive, one's negative, one's positive, one's negative. Okay? So again, that proves our definition that the slopes of perpendicular lines are negative reciprocals of each other. So this is a good review for parallel and perpendicular lines. If you want some additional practice, you can maybe graph a couple of lines and then write equations and graph lines that are both parallel and perpendicular to your line.